Good afternoon, everybody. Let's begin today's class. In the previous session, we were discussing about how to find the Fourier series expansion of arbitrary period. I had given few examples in previous class, also few questions for you all to practice. So first, we will begin with the introduction of Fourier series of arbitrary period. We have been discussing about Fourier series of period 2 pi, that means the length of the interval. Some length is given. So what is the length of this interval? It's upper limit minus lower limit, 2 pi minus 0. So this is the length. We get it as 2 pi. So this is known as the period of that interval. What do you mean by period? It is a time length. After that period, the function repeat itself. If you are talking about the graph, after that interval or that period of time, the graph repeats itself. So that is what you mean by periodic function. What do you mean by periodic function? A function with a specific period. If you have for different function, you will have different period. So you can say that sine and cosine are the two functions with period 2 pi. That is what you mean by periodic function. The sine and cosine are the periodic function. We have been discussing about how to find the Fourier series expansion of certain period where the period is not specific. That means arbitrary period. It may be anything, arbitrary period, which we usually denote it as 2L. The general arbitrary period we represent it as 2L. Then we find the length of the interval in a question. We will be asked to find the Fourier series expansion with a specific interval. We need to find the length of the interval and equate it with this period, standard period, that's 2L, in order to find the value of L. So general form of a Fourier series expansion in case of arbitrary period is given by a naught by 2 plus summation n equal to 1 to infinity an cos n pi x divided by L plus summation n equal to 1 to infinity bn sin n pi x by L. So this is the Fourier series expansion of function with arbitrary period. You all need to remember this formula, do not get confused. Okay, make separate notes for only these formula of Fourier series so that it's easier for you all to revise before the exam. So first question, I'll discuss what I had given in the previous class. We need to find the Fourier series expansion of f of x is equal to plus 8 where x lies between 0 and 2, and it is defined to be minus 8 where x lies in the interval 2 and 4. So this is the first question I had given. We need to find the Fourier series expansion of this. You can see that it is split into two parts, isn't it? From x lies between 0 to 2, function is defined to be 8. When x lies between 2 to 4, function is defined to be minus 8. So what is the interval now? 0, 4. Remember that first starting limit is 0, ending limit is 4. This 0, 4 interval 0, 4 is split into two parts. First part is where x lies between 0 and 2. Second part is where x lies between 2 and 4. So this is the interval. What is the length of this interval? That is upper limit minus lower limit. 4 minus 0 is 4. Next, what we need to do is we need to equate this with the standard limit. The standard series or standard period, it's 2L. We always consider in the case of arbitrary periods, you can look at here. This is arbitrary period, interval itself 0, 4. So the number is arbitrary. So you can compare this and say that this is a question on Fourier series of arbitrary period and the standard period is 2L, that you need to equate with the length of the interval which is equal to 4. So 2L equal to 4, that means L equal to 2. This is what we get the value of L. I hope this much all of you have got it. Okay. Let's continue. After we find the value of L equal to 2, what we need to do? We need to check whether the function is even or odd. What is the interval? 0, 4. Interval is 0, 4. How to check the odd and even nature? When you have the interval which is 0, 2L, you need to replace x by 2L minus x. This is what you have to do. And let me check, but one more way I'll tell you. If you want, you can check that way. F of x is equal to, you replace f of x by f of 2L minus x. What is L? L is 2. So that is nothing but 2 into 2 minus x, that is 4 minus x. So replace x by 4 minus x, it is 8. 8, isn't it? What is this? This is a constant which is independent of x. Whatever value of x you may put, this is not going to change. It remains as it is. So what we can conclude? What we can conclude? You are allowed to tell me the answer now. What we can conclude? What?
It's neither not odd or neither even.
Is it so?
It's odd, ma'am. It's odd, ma'am.
Odd. Why it is odd function?
It is minus of psi of x, ma'am.
Yeah, very good. It is minus of xi of x. Very good. See, you are allowed to remember these constant terms are there. No, they are not dependent on x. They are independent. 8 is independent term. It is not dependent on x. So in order to check the even and odd nature, if you replace x by 2l minus x, that's 4 minus x, it doesn't going to change the value of this. 8 is 8. 8 remains as it is. So you have taken 8 as phi of x and minus 8 as xi of x. So after replacing phi by 4 minus x, the value of 8 remains as it is because 8 is not dependent on anything. And 8 is what? It is minus of xi of x because minus xi of x. Am I correct? It is minus xi
Yes,
of
ma'am.
x, isn't it? 8 is equal to when you can write 8 as minus of xi of x. So you can conclude here is as phi of 4 minus x is same as minus xi of x. That's why you can conclude that the function is odd. Is it clear to everybody? I would like to repeat this once again. When you have discontinuous function, checking the odd and even nature varies. Take the first term as phi of x, take the second term as xi of x. Look at the interval. It's of the form 0, 2l. If it is of the form 0, 2l, you need to replace x by 2l minus x, where l is 2. So 2 into 2, 4, 4 minus x. Now replace phi of x, that x has to be replaced by 4 minus x. But 8 is a constant term which is independent of x, that's why phi of x remains as it is, which is same as negative of xi of x. We have got phi of 2l minus x is same as negative of xi of x. If so, we can conclude that the function is odd. If phi of minus x would have been plus xi of x, then we can say that f of x is an even function. But it is minus of xi of x, that's why we can conclude that f of x is an odd function. So what is the benefit of this? If f of x is odd, what we can conclude? The Fourier coefficients, that is a naught equal to 0 and an is also equal to 0. These are the two Fourier coefficients which are 0. Now, next what happens when these Fourier coefficients are 0? We need to find the third Fourier coefficient, that is Bn. Let's write the formula. What is Bn? It is 2 by L integral 0 to L, then f of x sine n pi x by L dx. So this is the formula. So 2 divided by L value is what? It's equal to 2 by 2 integral 0 to 2 f of x. What is f of x now? See the interval, it lies between 0 to 2. When x values lies between 0 to 2, f of x is defined to be plus 8. So f of x is 8 into sine n pi x by L. L value is 2 into dx. Next, here 2 to get cancels. What we can do? Let's take 8 outside. Integrate sine n pi x. What is the integration of sine n pi x? What is the integration of sine? Integration of sine
Minus
is,
cos n pi
yeah,
x.
minus cos n pi x divided by n pi x by 2 whole divided by the constant term. In this term, constant term is n pi by 2. So divide by n pi by 2. Limit vary from 0 to 2. Let's put the limit over here. You can take the minus sign outside, minus 8 into n pi by 2. When we take it to the numerator, it will be 2 divided by n pi. Now let us put the limit. when x is 2. Here 2 get cancels. What remains? Cos n pi minus lower limit when x is 0. If you put x as 0, it will be cos 0. Cos 0 value is 1. I hope this is clear. So from this, what do we get? 8 twos are, how much it is? Minus 16 by n pi. Am I correct? Or we have gone wrong somewhere?
Correct, ma'am.
Afterwards, what do we have?
Cos n pi will be minus 1 raised to n.
Correct. Minus 1 power n minus 1. Then what do we do now? One more thing we have discussed. We can take this minus sign inside and I can write it as 16 by n pi into 1 minus minus 1 power n. What I did, I multiplied this minus 1 to the entire term. That time it will be 1 minus minus 1 power n. Then one more thing we can rewrite over here is that 1 minus minus 1 power n. Okay, we can all you remember that 1 minus minus 1 power n. Suppose if n is even. N is even, what is the value? And if n is odd, what is the value? Power of n is even. That means this is minus 1. Minus 1 power n. Power of n is even. That means 2, 4, etc. Minus 1 power even number will be always positive, so 1 minus 1 will be 0. Similarly, 1 minus minus 1 power n, where n is odd, minus 1 power odd power will always be minus 1 itself. So 1 minus of minus 1 will be 2. So this thing you need to remember. When n power of n is even, we will get the entire expression value to be 0. When the power of n is odd, the value of this entire expression is 2. This you need to remember. And what is this? This is the value of bn. Bn equal to 16 by n pi 1 minus minus 1 power n. Now let us write the final Fourier series expansion. We know a0 and an values are 0 because the function is odd. Only thing you need to write is summation n equal to 1 to infinity bn sin n pi x by L. L value is 2. So let us substitute that summation n equal to 1 to infinity. What is bn? 16 by n pi 1 minus of minus 1 power n into sin n pi x divided by 2. Next step what we do is we substitute this result over here. The value of 1 minus minus 1 power n, it is equal to 0 when n is even and it is equal to 2 when n is odd. So what we do here is we substitute that. We know the value of it going to be 0 when n is even. Whenever maybe the here power of n will be even. In that case, the entire values expression will be 0. So you can neglect that even terms and you can write the summation in terms of only odd terms 1, 3, 5, 7, etc. up to infinity. 16 by n pi into 1 minus of minus 1 power n. What is that? It is equal to 2 into 2 into sine n pi x divided by 2. So this is equal to what? 16 twos are, we get 32 summation n equal to 1 to infinity. Am I correct?
Yes, ma'am. Take pi outside, ma'am.
Okay. Okay, you can take this pi also outside. 32 by pi. And what do we get over here? 1 by n sine n pi x by 2. Is it the answer?
1 by n
Yes,
square.
ma'am.
Where is the n square? From where you get that n square?
Only n, ma'am.
Yeah, it's only n. Maybe
Ma'am,
yesterday.
I have one doubt, ma'am.
Yes, ma'am. Yes, yes, tell me.
We have substituted n is equal to 1, ma'am. In so
Where?
we should put here, ma'am. We should
I
put
didn't get you. Repeat your doubt once again.
We should put for all n, ma'am. Substitute for all, ma'am. N, ma'am.
You can expand that and write, suppose if they ask you to deduce something, when sometimes it will be given 2 pi square by 8 equal to 1 by 1 square plus 1 by 2 square plus 1 by 3 square. Sometimes they ask you to prove this. In that case, you need to substitute for n and get that value. If they have asked you only to get the Fourier series expansion, then you can stop till here.
Okay,
You
ma'am.
got it?
Yes, ma'am.
Shilpa, what about you? Did you get this answer? Anybody else? Chaitranjali, are you there in class?
So,
What answer did you
yes,
get?
same, ma'am. But
Oh,
1 by n square you had given yesterday, na, ma'am. So I was confused.
okay. The answer is given to be 1 by n square, but we are not getting n square over here. So this is only correct. No n square value. You can stop till here. Done? Anybody has any other doubt? No? No other doubt?
No, ma'am.
Oh. Okay, we'll discuss the next question. What was that? F of x is equal to x square in 0 comma 1 and minus of 2 minus x whole square in 1 comma 2. Okay? Is it okay, everybody? Is this the question I had given? How many of you have worked
Yes,
it?
ma'am.
How many of you have worked on it? Okay,
I have
we'll
solved,
discuss.
ma'am.
Okay, we'll discuss this question. What is it said over here? So this is a discontinuous function. First thing is you see it is defined to be x square in 0 comma 1. It is defined to be 1 comma 2 in defined as minus of 2 minus x whole square in 1 comma 2. So what is the length of the interval? What is the length? You this 0 comma 2 it is starting one is 0, ending one is 2. 0 comma 2 is split into two parts. One is 0 comma 1, second one is 1 comma 2. So this is the original interval, and what is the length of this interval? It's upper limit minus lower limit 2 minus 0, which is equal to 2. And what is the standard period? It's 2L. 2L, if you equate it with the length of the interval, we get L value to be equal to 1. So this is the value of L. What do we do next? Next, what shall we do? Tell me, you all have worked out, isn't it?
Odd or even.
Check the odd or
Yes.
even nature.
So in order to check the odd and even nature, what do we do? Replace x by 2l minus x. We need to replace x by 2l minus x where l equal to 1. So we have to replace it by 2 minus x. Now what do we do? Phi of x is what? It is equal to x square. What is y of x? It's minus of 2 minus x whole square. Correct? Phi of x is x square. Y of x is minus of 2 minus x whole square. Next thing what we do is here phi you have to replace x by 2 minus x. So when both the sides, when you replace x by 2 minus x, it will be 2 minus x whole square on the right hand side. Now what connection does it have with xi of x? It's negative of xi of x. Am I correct?
Yes, ma'am.
Yes, ma'am.
Yeah. As it is negative of xi of x, we can conclude that function f of x is odd. If the function f of x is odd, a naught is also equal to 0, an also equal to 0, we need to find the value of bn. So what is the formula for bn? It's 2 by L integral 0 to L f of x into sine n pi x by L into dx. That is equal to L value is 1 integral 0 to 1. What is f of x when x lies between 0 to 1? When x lies between 0 to 1, function is x square. Be careful while choosing that x square or f of x. Next, sine n pi x by L. Sine n pi x, because L value is 1. This is sine n pi x. Now, in order to find the product of integral of these terms, that is x square and sine nx, take the first term as x square, second term as sine n pi x, then we shall use Bernoulli's rule to find the integral of product of two functions. So, according to Bernoulli's rule, what do we do first? We will keep the first term as it is, then we'll integrate the second term. So first term is x square, keep it as it is, integrate the second term. Integration of sine, we know that is minus cos n pi x divided by n pi. Am I correct? Integration of sine n pi x, it's minus cos n pi x divided by n, minus differentiate x square. What is the differentiation of x square?
2x.
2x. Next, what do we get then? 2x. Then integrate this term. Integration of cos is sine, but with the negative sign. Sine n pi x by n pi. 1 n pi already there, so it will become n pi whole square. Then plus sign. Differentiate 2x. Differentiation of 2x is 2. Integrate this term again. Integration of sine is minus, but there is a negative sign, so it will become plus cos n pi x divided by n pi square is there, so it will become n pi whole cube, and the limit vary from 0 to 1. Am I correct? It varies from 0 to 1. Next. Now we'll put the limits. What happens when we put the limit here? Just check to this term which is here, intermediate term. When you put the upper limit x as 1, sine n pi which will be 0. If you put x as 0 also, sine 0 will be 0. So this middle term will be 0. Next, check with the first term. Here minus 1 by n pi you can take outside. You can write it as minus 1 by n pi. Put the limits only for x square and cos n pi x. First upper limit is 1, so it will be 1 square, 1 into cos n pi, 1 into cos n pi. Then, now put the lower limit, minus. When you put the lower limit in place of x, 0 square, so 0 into cos 0, it is going to be 0. Then this term, it will be 2 by n cube pi cube. 2 by n cube pi cube, put the upper limit, it will be cos n pi, minus, when you put the lower limit, it will be cos 0. This is what we get it. Now let us continue this. What do we get when we continue this? It will be 2 into cos n pi can be written as minus 1 power n, correct? That minus 1 power n into this minus 1, I can write it together as minus 1 power n plus 1 by n pi. Am I correct? Minus cos n pi value is minus 1 power n, and here outside there is one minus 1 power 1. So altogether these two things I can write it as minus 1 power n plus 1 divided by n pi. Then come to this point, it will be 2 divided by n cube pi cube. Cos n pi can be written as minus 1 power n minus cos 0 value is 1. So this is what we get it. Now next what we can do is we can simplify these two terms and write it as all together. You multiply this 2 to both the terms. We get 2 into minus 1 power n plus 1 divided by n pi. Then 2 twos are 4. Correct? This 2 into 2 it will be 4. So plus 4 by n cube pi cube into minus 1 power n minus 1. Is it okay everyone? Anybody has any doubt? Anybody has any doubt? In the answer, how is it there? So we'll write the final answer. It's 2 into minus 1 power n plus 1 by n pi. In the answer, what they have done is they have rearranged these two terms by taking minus and outside. So if I take minus 1 outside from these two steps, what happens then? It becomes minus 4 by n cube pi cube 1 minus minus 1 power n. If I take minus 1 outside from these two terms, it will be 1 minus minus 1 power n. This is what we get. But you can stop till here. Doesn't matter. But sometimes in the books it will be these kind of answer will be there. But there is no difference between these two. Both are correct. Even you can stop till here. But yesterday I had given the answer to be like this. That's why today I have continued till here. Or you can stop till here or till this step. Then you write the final step f of x is equal to summation n equal to 1 to infinity bn. What is bn? 2 into minus 1 power n plus 1 by n pi minus 4 by n cube pi cube into 1 minus minus 1 power n whole term. This is bn into sine n pi x. Anybody has any doubt in this? Those who have asked a doubt in this question, anybody has any doubt?
Ma'am.
Hmm. Tell me. Any doubt? How many of you understood? Please raise your hands. Bhagyashree, any doubt?
No, ma'am.
Yes, are you there in class?
Yes, ma'am.
Are you practicing?
Yes, ma'am.
Please work out the questions. These questions, additional examples, so that you will be thorough with. But when you are learning for the exam, please work out the questions which I have given in the notebook. I mean, especially for your final exams. Okay. For your final exams, please work out the questions which I have given in the notebook. Those who cannot handle this subject, the rest of y'all, not a problem. Is it fine, everybody?
Yes, ma'am.
Is it okay? Okay. So till now, whatever we have discussed, let's have a brief introduction or just a reference for your exam. For your quick reference, I'll do that revision, quick revision. First, we have discussed about Fourier series expansion with period 2 pi. Fourier series expansion of period 2 pi. Period 2 pi means we will have two types of intervals minus pi comma pi and 0 comma 2 pi. Why I am telling this? Because it is happening. You all are doing that mistake. If there are some functions which can be easily solved by using the concept of even and odd functions, if you are able to understand whether the function is either even or odd, then you need not compute all the Fourier coefficients. Our main aim, we have a naught, an and bn. Suppose if the function is even, then Bn will be 0. Suppose if it is odd, then A naught also equal to 0, An also equal to 0. But this is what happens. Most of y'all see that textbook especially, and write the exam. Because of that, you end up finding all the three answers for A naught, An, and Bn. Because these type of questions will create a problem when you study for the exam. There is a shortcut method to do it, then follow it. Do not write it. Do not go to solve it, because the problem arises in finding the integration of product of two functions, especially using Bernoulli's rule. That's why I always expect you all to check this odd and even nature of functions. So there is a way to do it. How you can do it, I'll tell you all. So you have the interval minus pi comma pi, 0 comma 2 pi. This is what? This is period 2 pi. Here this is for period 2 pi. Now for arbitrary period. This is what you have to do it in your notebook also. This is for arbitrary period. Arbitrary period means L varies. Remember that L varies. So I'll write the general expression over here, minus L comma L and 0 comma 2L. That L may be anything. It need not be. Sometimes you will have the question on minus L comma L also. Then you have to keep it as standard and you have to proceed. You will get the answer in L. Otherwise, you may have the numbers like 2, 3, 4, etc. So here when you have minus pi comma pi and 0 comma 2 pi, you have to replace x by minus x. If it happens to be, if f of minus x happens to be plus f of x, function is even. If f of minus x happens to be minus f of x, function is odd. Similarly, in the case of 0 comma 2 pi, you have to replace x by 2 pi minus x. If f of 2 pi minus x happens to be plus f of x, function is even. If f of 2 pi minus x happens to be minus f of x, function is odd. The same concept what you have put for minus pi comma pi, put for minus L comma L. That is, replace x by minus x. If f of minus x happens to be plus f of x, function is even. If f of minus f of x happens to be minus of f of x, function is odd. And what you have put the formula for 0 comma 2 pi, apply that for 0 comma 2l. Instead of 2 pi minus x, you have to replace x by 2l minus x. So f of 2l minus x happens to be f of x, function is even. If f of 2l minus x happens to be minus f of x, function is odd. I hope you are able to understand the difference now. Is it okay this much to everyone? Anybody has any doubt in this? Checking the odd and even nature for different intervals, different class intervals. Is it okay?
Yes, ma'am.
Anybody has any doubt in this? Please ask. Very important this is. Because this is where you get confused. So you can make a short note of it even now, in the last page or wherever you have the place. So this much is very important. Now then one more thing you all know, if the function is odd, what if the function is odd, a naught is also equal to 0 and an equal to 0. If the function is even, bn equal to 0. This much you need to remember. Now when we come to that formula we know arbitrary period Fourier series of period 2 pi function f of x. General form is given by a naught by 2 plus summation n equal to 1 to infinity an cos nx plus summation n equal to 1 to infinity bn sin nx. Whereas in the case of arbitrary period, f of x is equal to a naught by 2 plus summation n equal to 1 to infinity an cos n by x by L plus summation n equal to 1 to infinity bn sin n by x by L. I hope you are able to differentiate between these two clearly. Now we need to find the three arbitrary constants. What are those? A naught, an and bn. Forget about the concept of even and odd functions. We'll write the general formula of this. So suppose if you consider the interval minus pi comma pi, then a naught is given by 1 by pi integral minus pi to pi f of x dx, where what is an? An formula is 1 by pi integral minus pi to pi f of x cos nx dx. What will be Bn? It's 1 by pi integral minus pi to pi f of x sin nx dx. This is where in the interval minus pi comma pi. What about the interval 0 comma 2 pi? That time a naught will be 1 by pi integral 0 to 2 pi f of x dx. What will be an? 1 by pi integral 0 to 2 pi f of x cos nx dx. Formulas are same. Remember that. The intervals change depends on the interval. The integral values, the limits change depends on the interval. Remember that. What is Bn? 1 by pi integral 0 to 2 pi f of x sin nx dx. Okay, this is when for the general period when the either of the functions are neither even nor odd. This is for neither even nor odd in 0, 2 pi and minus pi, pi. Suppose if they are either even or odd, that time what happens? Either even or odd. That time what happens? Only one case you will have. A naught will be whether the interval may be 0, 2 pi or minus pi, pi. A naught will be 2 by pi integral 0 to pi f of x dx. Whether it may be minus pi, pi or 0, 2 pi. When the function is even or odd, this is the formula. There is no other formula. An will be what? 2 by pi integral 0 to pi f of x cos nx dx. Similarly, Bn will be what? Bn will be 2 by pi integral 0 to pi f of x sin nx dx. Is it okay to everyone? Anybody has any doubt? Or anybody wants to ask anything? There are not so many formulas. They are one formula only, but depends on the interval. They are segregated into 3 steps. So if you remember any one formula sufficient, you need to do the alternate arrangement depends on the interval what is given. Is it okay, everybody? Please answer. If you have any doubt, please clarify. There are not, see, all these formulas are same. All the formulae what I have listed out over here are same, but it depends on the interval. It depends on the interval. And most of the cases, these last only will be used because you will be asked questions which are either even or odd. So that's why this only will be asked most of the time. Is it okay? Anybody has any doubt? Okay. So same formula you can apply that for this also. What? Fourier series of arbitrary period. Here also you can apply that. When you have, suppose if the function is either even or odd. Suppose if it is either even or odd. What happens in that case? Either even or odd. In that case, a naught is given by 2 by L integral 0 to L f of x dx. An will be what? 2 by L integral 0 to L f of x cos n by x by L into dx. Similarly, Bn will be 2 by L integral 0 to L f of x sin n pi x by L into dx. This is when the function is either even or odd. In general, for the interval c, c plus 2l, because in the question interval will be given. It may be minus l, l or 0, 2l. Some interval will be given to us. In that case, how do we go forward? Same formula, just see here. A naught will be, we will not be writing this 2. We will be writing 1 by L and this interval, whatever may be the interval which is given, that we will be writing. Suppose if it is minus L comma L, we will write it as minus L comma L. Suppose if it is given 0 comma 2L, we will write it as 0 comma 2L. Remember that. What is the difference between this and this? Only when the function is either even or odd, this 2 will be used and it will be 0 to L, or else it will be 1 by L into 0 to 2L, whatever interval will be given. If it is 0 comma 2, it will be 0 to 2. If it is minus 2 comma 2, you have to begin with minus 2 comma 2. All those corrections you have to do it. So remember the general term. Remember the general term, then you can do the modifications as required. For that you need to practice. Without practicing, you cannot work out or solve anything in Fourier series. You cannot read a Fourier series. You need to practice this. Remember this. It is not any other thing which you can read and write. It will not happen. Whoever I am saying now, you all do not have the practice of writing without seeing the book. Most of the time, if I give, I think even yesterday's question, only from few people I got the doubt. Others, you might have got the answer. I'm not saying you have not got the answer, but there may be some people who have not worked out at all. I'm not saying you should work out the additional examples I have given. You can work out the questions which are there in the notebook. That is sufficient. Take that question, whatever question may be given, say f of x is equal to 2x minus x square in the interval 0, 3. Take only the question and start working on it. That time you will realize where you all are going wrong, where is the mistake, why I am not able to do this problem, what is the formula related to this, how to check the even and odd nature of this function. This way, if you start thinking, you will be able to solve these questions. Or else just by reading the question and going for the exam won't work out for Fourier series and Fourier transform. Not even for this entire course, 18MAT31. Okay, so on Monday, where there will be a test 3 to 4 p.m. 3 to 4 p.m. there will be test on Monday. What's the date on Monday? 21st. Am I correct? 21st December 2020. There will be test 3 to 4 p.m. You need to upload your answer scripts in Teams. You need to upload your answer scripts in Teams. Only if you are honest, upload your answer sheets. Or else please do not upload. You can sit and practice. Is it okay, everybody?
Yes, ma'am.
Okay, so practice the questions which are there in the textbook. You need not practice the new questions because after each session I have given new questions for you all to practice. So you can practice the questions which are there in the notebook itself. Okay, if anybody has any other doubt, please contact me. I may be late, but I will give the solution as soon as possible. Done? Anything anybody
Ma'am,
wants to
lateral
ask?
entry students also attend the exam, ma'am.
If it's your wish, because I have started from the beginning, no, I'm keeping only the questions from Fourier series of arbitrary period and period 2 pi, because this I have started after lateral entry students have come. Because this is the revision part I am keeping. I am not keeping the entire syllabus. So if you are confident enough to write the exam, you can attend that exam. That's it. If no, take those questions and start practicing on your own. But if you are honest, then without seeing if you have practiced something, then only upload in Teams. I do not want to correct the answers of seen and written copies. I do not want that. Anybody to see and write and forward it to me. I do not want such answers. So if anybody is not able to answer that paper, not a problem. Take that question and start practicing on your own. Because I am saying this, I am conducting this exam because I have started this revision. This is my 8th class. 8th class, and for Fourier series of arbitrary period, Afterwards, half range Fourier series is there. Then we have practical harmonic analysis. And for combining all this in a syllabus, 8 hours is allotted. But I have gone slowly and I have explained everything for you all. So it's your decision. If you all want, you can take the exam or else not a problem. But there will be a test on Monday. Okay? See you all on Monday. Thank you, everybody.
Thank you.
Thank you.